wait till you get up.
Shut up.
Hold on. Okay, fine.
Okay, 8-1. This is direct variation. Okay, so we did this in class, but if you missed it, this is going to be a perfect catch-up for you. So, direct variation, you definitely want to write this down. It's a linear function. It can be defined as y equals kx, where k is a constant of variation. Remember that k is a constant of variation because they're always going to use that for any type of variation. All right, it's basically the constant. It's also can be seen kind of as like the slope, but this isn't going to be that simple to think of it to kind of define it, constrain it to just being the slope, right? But the big thing that you'll need to be able to do is to recognize the terminology, right? Y varies directly as x means that you're turning this into the equation. Whatever is in the position of y is y equals, right? K times whatever is in the x position. Okay, so this terminology creates this equation. All right, that's going to be huge. And this can be modeled as a proportion, and I'll show you how to do that in the examples, okay? So these are the notes, and let's go to the examples. So if y varies directly as x, remember, y varies directly as x, you should see immediately that this means y equals k times x, right? And y equals 25 when x is 15. Okay, so this is the first way to solve this. Two ways to solve it. I'll show you both ways. All right, the first way to solve it is plug in our scenario, okay, to solve for k. So y is 25 and k is 15. Okay, so that's supposed to be a 15. Okay, so you could solve for k here. Divide by 15, and we've got k equals 5 over 3. Now we can use that 5/3 to solve for any x and y. Okay, so our new equation is y equals 5/3 times x. Well, we know that y is going to be 40, and we're going to try to find what x is. So 5/3 times x. So in order to solve for x, we're going to multiply both sides by 3/5 to get x by itself, and x is going to be equal to 24. Okay, now another way to do this is once you get your y equals kx, right? We can always turn this into a proportion. And the way you do that is you solve for k before you even try to find x and y. Okay, so get k by itself. So to get k by itself, you're going to divide both sides by x, so y over x equals k. Okay, but that k is never going to change for this whole problem, for the whole direct variation. The k is never going to change. Okay, so you could pick any x and y, and it'd be, if you have it as y over x, it's going to be equal to k. So I can have y1 over x1 equals y2 over x2. Right? So now I can just define any points, right? This first one is y1 and x1, and the second one is y2 and x2. Oh, other way around, but yeah. So I could just plug all those in and solve that proportion. So to do that, I've got 25 over 15 equals 40 over x. Okay, cross multiply and divide, and you're going to get x equals 24. Exact same answer. All right. Now, you aren't necessarily always going to have just easy, typical x and y variables. Okay, you can manipulate those variables in ways. So we've got number 2 here. We've got a is directly proportional to b cubed. Right, that terminology is directly proportional to means the exact same thing as varies directly as. Okay, so just know that that's also going to be used. So we're going to have a equals k times b cubed. Not b anymore. It's just b. It's actually b cubed. Okay, so we'll solve this in both ways. All right, the first way is to plug in our what we have. So a equals 10, b equals 2. So k times 2 cubed. All right, 2 cubed is 8. So we divide by 8, and k equals 10 over 8, which is 5/4. Okay, now we use that 5/4 to solve for a when b equals 4. So a equals 5/4 times 4 cubed. Okay, 4 cubed is 64. 64 divided by 4. Oh, basically this can cancel out with one of those. So we basically have 16 times 5, which is 80. Okay, now that works perfectly fine. Other way to do this is to turn this into a proportion. So when you manipulate this equation right here and get k by itself, we're going to get a over b cubed. So a1 over b1 cubed equals a2 over b2 cubed. Right? Well, I have a1, b1, a2, b2. Okay? So we're going to do the same thing. Plug all those in. 10 over b1 cubed is 2 cubed, so that's 8, equals a over 4 cubed, which is 64. So 640 divided by 8 is 80. Same answer. Okay? There's some more word problems on the back. Let's work on that. Alright, so obviously the calculation for this is pretty simple, so the word problems are going to be where you're going to basically have to do the most amount of work here. Alright, so for this one, number 3, the key is to translate the first sentence into something we can work with. Right, so we need to define variables and then create an equation out of it. Right, so to start here, we've got the amount of hydrogen produced when sodium is added to water varies directly as the amount of sodium added. So this whole thing here varies directly to this whole thing. Okay, so those are going to be our two variables. We'll call the hydrogen one H and the sodium one here S. Okay, so that helps us create our equation H equals Ks. Okay, we'll solve this with the let's say the proportion method. Okay, so let's get K by itself. So we've got H1 over S1 equals H2 over S2 when you solve for K. Alright, so we can plug all this stuff in. We've got an S here, right? 92 grams of sodium, so that could be S1, produces 4 grams of hydrogen. 10 grams of hydrogen could be H2, and the amount of sodium needed, so what we're looking for, is S2. So that tells us pretty easily what we need to plug in. We've got 4 over 92 equals 10 over S. Okay, so we're going to do 920 divided by 4. So S equals 230 grams. Okay, so we need 230 grams of sodium in order to produce 10 grams of hydrogen. Alright, number 4, just another one of these regular problems, but we're going to manipulate the B again a little bit more. So we've got A varies directly as B plus 5. Okay, so we've got A, 1, or I guess let's just start by doing the equation. A equals K times B plus 5. Okay, we can create that proportion again. So A1 over B1 plus 5 equals A2 over B2 plus 5. And we can plug everything in that we have. So we've got A1, B1, A2, B2. So 2 over 1 plus 5 is 6 equals A over 4 plus 5 equals 9. My A's and my 9's look way too similar. That's an A. Alright, you multiply, divide, we have A equals 3. Alright, and the last problem here. We've got the period of a pendulum is directly proportional to the square root of the length of the pendulum. So the period, oh, I don't want all that, period, P, is directly proportional to the square root, right? Don't forget that. It's going to be really, really important. You got to remember the square root of the length of the pendulum. So that's going to be an L. So we've got P to create our formula equals K times root L. Alright. Now, to get K by itself, we do P1 over square root of L1 equals P2 over square root of L2. Okay, so we have L1 right here. We have P1 right there. This, what we're looking for is the period P2, and we have L2 is 1 meter. Now remember that the 1 meter and the 64 centimeters aren't going to be able to be in the same equation. You got to have the same units. So we'll turn 1 meter into 100 centimeters. Okay, that'll be our L2. So P1 is 1.6 over the square root of L1 is 64. P2 is what we're looking for, and L2 is 100. So we've got 1.6. Basically, we're going to have 16, right? 10 times 1.6 is 16. and equals 8p, so p equals 2 seconds. That's all for direct variation.